it is in Google, New Moodle, it's in Moodle, and the other thing is it's still in section 3, chapter 3. It's probably one of the few things you can get at. Okay, now I will be adding to it, but in the first section up there, tomorrow we'll look at that mean value theorem again a little bit, and what I'd like to look at first is this section right here. These are the optimizing problems, and 19, isn't that the circle head semicircle one?
Yes.
And 31, okay? They're both very similar, and I would like to do, I think, 31 and not 19. Questions on that? 31 is burying the cable, okay? Any questions on that? And so, so you won't have to copy this. It just gives you an idea where we are, and gives you an idea what to start studying for. Okay? Because this is not an easy chapter. Yes?
48.
Where's this go?
This one over here, 48. Yes, I will, but not now. Are you going to be there Wednesday morning? Okay. I like that problem a whole lot, and I found many people had trouble with it. Okay?
You didn't pick mine up. It's not late, you just didn't pick it up.
Are you sure?
Well, it was like 10 seconds after.
I was doing the video game.
Okay.
You get 50%.
Today, we're going to do some of this optimizing, or not optimizing, estimating. Okay, it's going to bug you a little, and the reason it's going to bug you is you can get the exact answers on your calculator so terribly fast. Why would we go through all this work to do that, and especially today? There was a time it made some sense even to run it. Well, I'm going to show you in a few minutes how this thing gets developed further. And that's why we have to get started now, so you can appreciate it later. Okay? Now, let's see here. Let's try this problem first, so you all have a pretty good idea of how it works. I'm going to have f of x equals x over x plus 1. Okay? Now, I would like to estimate what f of 1.1 is. In other words, I'm going to put that in there. Now, it's very easy to calculate what is f of 1. What is f of 1 equal?
1/2.
1/2, okay? And so we have the ordered pair 1 comma 1/2. And so what happens here is this. When I have a curve like this, I will have a line, and we're going to develop this line. And when we're very close to these intervals right here, this is what we're going to be talking about today, we're going to be very close to getting the correct answer. Two things we have to do. One is calculate it, and then calculate our error. You got that? Because I will ask you to calculate the error. And I'll show you a little bit also where we're going. Well, we're not going to go there. In Calc 2 you go there. Okay? So, I'm going to develop the equation of the line, and we've done this many times over. I'm going to first find the slope of the line. So I'm really going to find that at 1. Not at 1.1. I'm going to find the slope at this point. And I'm going to have the line, which goes through this point. And what is that line? Well, what is the derivative of this function here? What is f of x? What's that derivative? Okay, and so low, and what's the derivative of the high?
1.
And then it's going to be x.
Is it minus?
This minus sign.
Oh, oh, yes, I get you. Yes, I get you. Okay, all over x plus 1 squared. Okay? Which turns into 1 over x plus 1 squared. Okay, so what's the slope here? Very good. Yeah, 1/4. Okay? So what's the equation of the line? That's that L. Oh, I don't have the line. Oops, I was going to write that up.
How's that equal?
Let me write something up here a minute. Here's what we have. This line, L sub x, that line, is going to be equal to f prime at a times x minus a plus f of a. We're going to this point. Any questions about how do you get this? Yes?
Can you explain it?
Okay. The derivative is at this point. That's a slope.
Oh,
Oh.
Okay? And then this usually is this point, this is my f of x kind of thing minus that, which we'll do pretty soon. And now the author says this is an estimate of f of my value that I have pretty soon, which is going to be 1.1. Okay? Now, so here we go. So my equation of the line is going to be L sub x equals 1/4 times x minus 1 plus a half. This is the point. Okay? And so this turns into 1/4 x minus 1/4 plus 1/4, which equals half. Yes, I was thinking ahead. 1 over 4x minus plus 1/4, which equals 1/4 times x plus 1. Okay? That's my line. Okay? Now, so what is the value at f of 1.1? It's going to be approximately this. See, this is my f of x. It's approximately that. And so that's going to be 1/4 times 1.1 plus 1, which equals 2.1 over 4. Okay, now, this is what we have to do at this point. How big an error do we have here? How big of an error do we have? Okay, this is the approximate answer. So what we'll do is put this in our calculator, and I think I did that. And did I get it? Yes. No, I didn't do that either. This is going to be, figuring this out, 1.1 all over 2.1.
Yep.
Okay. Pardon? This is 524,
Yeah,
and this is 525. Okay, and then the author tells you how to do. It's less than 0.5%. Okay, and that I need to know, because later on that becomes pretty important. So, oopsie, just a second here. Is it supposed to be 5.24?
No,
0.524.
Like this?
No. 0.524.
Okay, gotcha, I gotcha. Okay, and it's supposed to be here. Okay, and the author says, how do we find the error? Percentage error, 100 for the percentage, because we're going to give it in percents. And then we have the approximation, which is 525
minus actual.
minus the actual.
So it's
Okay.
0.01.
And, oopsie, it's supposed to be here like this. Okay, and that turns into less than 0.2%, or it's a little more than 0.2%. Okay, so know how to get that error calculation. Okay, Yeah,
Can you go over the equation? They give an equation in the book for what you have there with the f of x is equal to L of x. I'm not really quite sure on that. And then up, like kind of in the middle there.
yeah.
It's on page,
It's on the board right there.
yeah, that one.
Yeah, he means that right there.
Yeah, I guess the one on the
Is that
board
equation?
is what I mean there. So, when they, like,
Hey, please don't talk through it.
for 7 and number 10, they give you an A, so do you automatically fill in the A right away for those?
Yes.
Like, once you set that up, you fill the A automatically?
I hope you've been listening, because with what happens there, we're going to go to a couple other problems ahead. I have given, it's behind the whiteboard what your assignment is. Okay, 7 through 12, it tells you the point. But now let's take a look at 13 through 19.
Yeah.
Okay? Now, I was going to give you 22, but I think this is going to take us too long. Okay? So 14. In that problem, well, let's go 16 rather. Okay? 16 is the cubed root of 65. Okay? Now, what number is easy to calculate on?
64.
64. Cubed root of 64
It's 4.
is equal to 4. Okay? So, now, what, here is the y equals the cubed root of x. So x is equal to 64, and the other, see, this is my ordered pair. Okay?
Why 64?
Because
That's
it's
the
even.
value each.
Because you can get a cube root of it.
cube
So it's 65.
It looks better.
Okay?
Okay.
Now, so now you work it from there. Okay?
So you do,
Can you keep going?
yeah,
Pardon?
can you keep going?
I'd rather not. I've got so many things I have to do.
You're at the
Okay,
wood, though.
this is equal to f of x. Okay? And so f prime of x is equal to what? This is equal to x to the 1/3.
1/3 x to the negative 2/3.
Okay? Negative, right? Okay, which is equal to 1 over 3 times x to the cubed root of x squared.
Yeah.
With me? Okay, now we need this value. And that turns into what?
What are we plugging in?
This equals 1 over 3, what's this number?
Are we putting a 4 in?
4, or are we plugging in 64 again?
We're plugging x. Which one is x?
64.
Yes, right. So we're doing that. And the cubed root of 64, see, what we'll do is this.
Square.
The cubed root of 64
Squared.
Which
squared.
is 64
16.
times.
That's 16.
Oh, wait, never mind.
Okay.
Times 3 is 48.
Okay, so my equation becomes y, or that's an L sub x thing, is equal to 1 over 48 x minus 64 plus 4. Okay? Now you clean that up. And then when you get it all cleaned up, then you plug in 65 for
For
x.
the original?
Yes. No, with what you have here.
Oh, the,
Okay. Okay, now, we'll probably get back at this a little later, but I want to do something else next. Watch carefully, because you get an idea why we're doing what we're doing.
No.
We have here y equals the sine of x, and what I'd like to do is figure out when x equals 0. If x equals 0, what does y equal?
0.
Okay? Now, with me on all the way here. Okay? So, if I take, this is f at x, f prime of x equals how much?
Cosine of x.
And therefore, f prime at 0 is equal to 1. Now, watch what happens here. Therefore, my equation that I'm looking at, my line question like this, is equal to, what's the slope? 1.
1.
1 times x minus 0 plus 0, which is equal to x. Okay? Therefore, the approximation here is sine of x is approximately equal to x for x near 0. Near 0. Okay? Pardon? Okay. Now, let's check this out. What is the sine of 0.1? Get your calculators and do it. Okay? I will do the same. Okay? Better make certain it's radians because it doesn't make any sense otherwise. Okay? Agreed?
Yeah.
0.998. Okay? Now, the next question I have is this. How many degrees is 1.1 radian? Will you make that change for me? So we get an idea what we're talking about here? 0.1 radian. And what's the conversion factor? 180 over pi. Okay, check it out. Tell me how many degrees this is.
5.7 degrees.
5.7 degrees. That's a fair number of degrees. Okay? Let's try something else here a minute. What is the sine of 0.2?
Double that.
Yeah, but not double this. You double this. Now you heard what Grant said. Double this. So we're 10, 11 degrees. What does this turn into?
0.19867.
Is this an 8?
Yep.
Okay. And let's do one more to see how bad it's becoming. And it's not really too bad. 0.4. Well, I doubled it. And so that would be
0.3894.
okay? So you see, we're moving away. Now, why does this work? Let me just flip this one off and watch what I have here. Okay, notice what I have. Here's the sine of x. Are you watching? Ben, will you watch this too, please, carefully? Watch what we have here. Okay, and here's my line. Okay, so in this neighborhood, right here, we're very close all the way along. See that? Therefore, we can approximate it that way. Okay, and this is called linear. Okay, now, the Taylor series, which I showed you the other day, I'm going to develop a little bit more on the overhead in just a bit. What I'm going to do is this. I'm going to take a look at a number of other functions. Here's the first one. Here's a look at the second one. That's no longer linear. This is a curve. What degree is this thing? Third degree. Okay, what's the behavior of the end behavior of one like that? Up. Okay, here's it's going to run here. What's on this side?
Down.
Okay, you're very good. It goes like this. Okay? Now, then I'm going to do this one. And notice this is a plus, but what degree is this one?
Fifth.
And that's going to be what? Down and? Okay, it's going to be flipped to this one. Now notice this one. Now, these are just building on it, but I want to show you some other things here. Notice 3 factorial, 5 factorial. Try this for me. What is the 5th derivative? What is the 5th derivative of this number?
The 5th derivative.
Factorial 5x.
Not quite, but you're close. She says it's factorial 5.
Oh.
120.
Yeah, I don't care about the 120. I wanted the factorial 5.
Darn.
Okay? Now, do you see what happens over here? These things are not so strange. They deal with finding derivatives. Okay, and I wanted to show you this, and next, I think I've done about what I wanted to do there for first, and now let me just show you some things. We saw this line. I'm going to take this out of here, and, oopsie, get out of here. And I'm going to graph this one. Oh, see? Now, you'll notice, the other one was over here. We're going a little further. See this?
Yeah.
Okay, and this is called a Taylor series. And now look at the next one. And I'll just get this out of here. And you see now, I'm all the way over here. And quite a range here where one is right on top of the other.
Keep going.
Okay, I'll get rid of this one.
We don't have
And-
to do this in this class, right?
Oopsie.
Apples. Go back.
Undo, you probably
Go,
gonna
no,
want
no,
Go
no,
forward.
no,
No,
go forward.
Undo,
No. Undo.
Undo. Yeah.
There we go.
Hey, thank you. Okay, is this the one we're gonna look at?
Yeah.
Okay, and then we'll get rid of that one, and we'll get this one. Okay?
We don't have to do this, right?
This is how your calculators calculate sines and cosines and tangents. It uses this kind of a Taylor series, okay? Because it just doesn't magically have the sine curve is going to go this way. It has to have something that generates the sucker, okay? And this is the stuff that you need to know if you were going to program that kind of stuff, okay? And I'll just go to give you this one here and get rid of this. And look at how much that one is. Yes?
This is probably a stupid question, but why are they all odd numbers?
Why are they all not odd numbers? Okay, that is not a stupid question. It's wonderful that he noticed that. What do you think the cosine is?
Even.
Even numbers. Okay? And why is that? Well, we have to get to the point of generating this thing through a series of many derivatives. And after you do a couple of them, you're going to find out these patterns start flipping out at us. Okay? Now, the other day, we were on page 620. And let's just go there a minute. 620. And also take into consideration Grant's question. Okay? Now, we're looking on page 620. It says sine and cosine. Notice the difference? The sine starts at x. The cosine starts at 1. The cosine is even numbers. The sine is odd numbers. Okay? Now, look at the one right above it. Look at e to the x and how that goes. 1 plus x squared over 2 all the way through. Okay? Now, I'm just giving you a little bit of a taste of why we're doing something that seems like a lot of work today. Okay? Because later on we're going to need it, and if we have a little bit of a grasp of this, it's going to be a lot easier when we get over there. Okay? Now, let me ditch this. Oh, by the way, this was a Sunday activity for me. I was thinking of, I haven't used my Inspire calculator recently, and I thought, boy, I'm going to have to get that thing working so I can show you this. And then I thought, I'll bet Desmos can do it. And wow, was that fast and neat. Okay? Now, let me show you something else. You know these things. You probably know a lot more about this stuff than you think you remember. What is this series? 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... What does that exactly equal?
1 over infinity.
One.
That is equal to 1. Now, okay,
Dang it, there.
hey guys. Okay, now what is this? What happens if I just go from this point? What is 1/4 plus 1/8 plus 1/16?
1/2.
Notice it's this one.
Yeah.
Okay, what is this one all the way through? Okay, that's rather amazing. Okay, now you were taught that first semester. This is an infinite convergent series. And when I have a convergent series like this, what's the sum equal to? The first term over 1 minus r. What's r? Ratio. That's the ratio. And what does the ratio have to be between? 0 and 1. Big deal. Okay? It can't be bigger than 1. It'll blow up. Okay? So it's between, actually it's the absolute value less than 1. Because it could be negatives too. Because you can flip back and forth that way. Okay? I want to do that now? No, I don't. Okay, so you have a whole bunch of these. Now you notice this thing isn't all that foreign from what I had up there a while ago. And this is how it works. And this is part of the story of why we're doing what we're doing. Okay? Now, we've got to do a few other things here today. Grant, you were questioning a while ago about the procedures.
Yeah.
You're getting it now?
Not really.
Okay, but you weren't here Friday, so, okay. Now, just a second here, I want to look at something a minute, and, okay, we have this. L of x, this is my line, is equal to f prime at x times x minus a
Okay, why are you putting it?
plus f of a.
Why'd you put an X in there now, this time?
Oh, this is supposed to be an a. This is supposed to be an a, because I made a mistake. Okay, now,
Does it matter in the book? Okay, never mind.
yeah, this is one of the first, that's that equation. Now, this is approximately equal to f of x. Now watch what happens. I'm gonna go from here, I'm skipping this one, I'm gonna go this way. So f of x, and I'm gonna subtract that from each side. Okay, f of a, like this, is approximately equal to f prime at a and x minus a. Okay, any questions about that? What is this here? That's delta y.
But
Okay, what's this? Delta x. Okay, now let me show you something else, and then I'll erase that because I want to get back to this. Do I want to? Oh, that's okay. Okay, let's just leave it this way. I'll just simplify it like this. Okay?
okay, well, why is that helpful?
Yeah.
I will get that for you in a moment. 2 reasons. I've got 2 of them. Let's do the first one this way. It goes, my example for the first one on this is this. I have a balloon, and let's see, how does it go? Surface area, okay, a balloon, and I'm going to change my surface area, or the radius of the balloon, from 4, it's going to go down to 3.9.
Oh boy.
Okay? Okay, now, what is going to be the rate of change of the surface area? Okay? And now, you could use this number, we're capable, but we're going to use this idea. Okay? And the surface area of a balloon, so we have surface area is equal to 4 pi r cubed. Squared. Okay? Like that. Okay? Now,
It's just pi or squared, isn't it?
4 pi r squared.
Sure.
Okay? And the derivative of this is 8 pi r. See that?
Yeah.
Okay, now, this one is pretty easy to do, and so I will do that. So the change in the surface area, this is surface area change, the change in the surface area is approximately equal to 8 pi times 4 times the change in x. In this case, the change in x is, so this is going to be 32 pi times the change in x, which is a negative 0.1.
Why do you use a negative? Because it's going down? Like, I understand that, but do you have to use it?
Absolutely.
Okay.
Because you notice, as you're going down, the surface area is going to become less.
Yeah.
Okay, yes?
Where does the 4 come from?
Where does the 4 come from?
Original radius.
The 4 comes from here. where I'm starting from. And why do I choose that? Because that's a nice number. This isn't such a nice number.
Yeah, but what part of your formula above is that?
Yeah.
That's this part right here, and the 4 is A.
Shouldn't be.
No, but shouldn't it be pi r squared instead of 4 pi r squared? Because you wrote the 4 because you were going to do 4 pi r cubed. So shouldn't it just be pi r squared?
This 4 stays.
No, that's
why,
area.
why do you need the 4 there though?
Here,
Because he's trying to find, well, yeah.
surface area of the sphere. The surface area.
Oh, you're doing.
Okay.
Okay.
We're doing the surface area of the sphere. Okay? Okay. Now, you can make this calculation.
Yeah.
Okay? That's an approximation. That's how we're using it. Okay, that is one thing. And the other is this. I was asked why this stuff. Here's one, and you'll do a couple of problems that way. The other is this. I'm going to make this look like this. Delta y over delta x is approximately equal to f prime at A. Now, in this case, this is approximately so, but if I want to make it equal, then I do the limit as delta x approaches 0 of this thing, then it's going to equal my function f at x, that's equal to f prime at x. It's going to be exactly it when it goes to 0. But when we're in the neighborhood, it's this way. Okay? Now, now just remember this a minute. I'm going to show you something else. We'll take an easy one. Y equals f at x, which equals x squared. Okay? Now watch this notation. This gives me delta y over delta x, because I'm finding the derivative of that, is equal to 2x. Okay? Now, we're going to do some differentials, and we're going to treat like this that I can divide by this. And so this is going to become dy equals 2x dx. And we'll be using this a lot in the next couple weeks. In this form. Okay? And we're going to need that. We're going to need that to undo all the stuff we've been doing. Because we're going to do antiderivatives next.
Yay.
Okay?
When are you planning on taking your exam at the end of April?
Pardon?
Our exam will be at the end
I
of
have no clue. Yes?
So how does the dy equal 2x dx? Like, what does that mean?
Okay.
Because he
Now.
just multiplied it
Now.
by the.
Okay.
Okay.
But how do you solve, like, dx? Can you, like, how do you solve that?
We will learn. You don't know now.
Okay.
But, and I won't get that next week, but the week after that, and then we'll start working there. Okay? Now, on this, check some of the stuff that's in the book. I haven't talked about all of it. Okay? There's some good stuff there that has to be done. Now, let's take a look quickly at the assignment so that it'll be doable for tomorrow.
What is it?
Okay,
Mr. Kramer.
here we go.
Mr. Kramer, what is the assignment?
Oh,
Is it one?
see, I do have 26. 25, I don't have 26. No, that's okay. Okay, 25 and 31. Boy, that's kind of, you up 25, 23. Okay, now, I got 2 in that group. Okay? Now, we've got a couple minutes. Let's take a look at that group 31 through 37. Okay? And of that group, which one do you want?
31.
32.
30,
32.
32. I like 32 very much. It's the easiest one of the bunch. E to the 2x. Okay? So that's like y. And so what's the derivative of that?
2e to the 2x.
So the answer is dy equals 2e to the 2x dx. We're done. We're off to the next problem.
Can we do, alright,
Yes.
number 31, please.
No, I told you one. Okay? Now,
So are we solving it for that every time then?
Yes.
Yeah, okay.
instead of this kind of notation, f prime notation like this, or this kind of notation, now we're going to use, and these are differentials. Okay?
Hey, you know we don't have school Thursday, right?
Oh, you don't?
No, so.
I know.
Test on
The next one.
Next Thursday. Teacher burger.
Otherwise, I could come.
it. Yeah, you'd be the only one here. All right.
Okay. Okay. We have a couple of minutes. If nobody has a question, DeVries gets the next one. Yes.
12.
12. Okay. Now, look what we have here. You're going to like 12 in that it's an e to the x, and a equals 0. So my ordered pair is 0, 1. Got it? F prime at x equals e to the x. So f prime at 0 is what? 1. So my equation is y equals 1 times x minus 0 plus 1, which gives me x plus 1.
Where'd that last plus 1 come
Can you
from?
pull on
Right
this?
here.
Why?
It's when you put 0 into the original?
Yeah.
Okay.
Way back, you found out this is how you write equations.
Okay.
Okay. So, Mr. Kramer, then, you do that for every equation, then you first find the derivative, and then you plug in whatever the derivative is, or whatever the a is.
Yes. Okay, now, hey guys, one thing we haven't done yet is to solve this one now in this group. And that is, we're going to find the value of this at 0.05. Like that.
So you just plug in 0.05.
So it's just 1.0.
Yes.
Why do you say f prime is 0? A equals 0.
Okay.
So it's my question.